Good morning, sir. I am Jovelyn Unto. I'm BS Ed Science 2B. So now I'm going to discuss or give an example about Chapter 7, Chapter 12, and Chapter 13. So let's find out. In example number 7, we have here the problem and also the solution. So first, we're going to establish whether either reactant is present in excess of equilibrium. The amount taken are the number of millimole Ba squared is equal to 100 ml multiplied by 0.0100 millimole over ml is equals 2 or 2.00. So in second one, number of millimole in IO3 is equals 100 ml multiplied by 0.100 millimole over ml. So the result is 10 or 10.0. So in this case, we already know the information about the two problem in which the Ba squared and IO3. So the number of millimole exists of NaIO3 is equals 10.0 minus by 2 times 2.00 is equals 6, as we can see in the presented image. So in this case, kunin naman natin yung value ni IO3. So in which since we get the 6.0, so magiging yan siya, magiging denominator yan siya ng millimole, in which mayroon tayong 200 ml plus 100 ml is equals 300 ml, then copy the 6.0 millimole. So the result is 0.0200 mole. So i-convert naman natin into molar solubility. We have the value of solution which is 0.0200. So where 2 solubility represent the iodate contributed by the sparingly soluble, find the provisional answer after making the assumption that is. So therefore, the solubility is, kung isasalin na natin dito yung constant, in which meron tayong 1.57 times 10 raised to negative 9, then divide by 0.0200 close and open, it has exponent of 2, so the result is 3.93 times 10 raised to negative mole. So since provisional answer is nearly 4 orders of magnitude less than 0.0200 mole, so our approximation is justified. This is the example of chapter 12, which is the principle of neutralization titrant. So the first one is, we have here the problem and also the solutions. In initial pH, first calculate the pH of a 0.1000 mole solution of the acetic acid. So here we have here the square root of 1.75 times 10 raised to negative 5 times 0.1000, so is equals, we got the answer of 1.32 times 10 raised to negative 3 moles. So the pH is equals negative log close and open 1.32 times 10 raised to negative 3. So we got the answer of 2.88. So that is the value of pH. So by getting the acetic acid, so we have here the 50 0.00 ml times 0.1000 a mole minus by 10.00 ml, then multiplied by 0.1000 ml, so over 60.0 ml. So the result is 4.00 over 60.00, so mole. So that is the result. So the 10 ml times 0.100 ml is the result of these two problem is 1.00. So in which parang gisegregate lang yung 1.00, then copy the 60, which is imbis na magiging ml siya, i-transform natin into mole. So we got the answer of 1.000 60.00. So now for the 10 ml volume, substitute the concentration of acetic acid into the dissociation constant expressed of acetic acid and obtain. So dito na tayo. So yung constant naman yung hanapin natin. So we have here the 1.00, then the result kanina, the result of the acetic acid kanina, copy the 1 and 4 and divide by, we have here 1 over 60 and 4 over 60, and we need to solve it. So the result is 1.75 times 10 raised to negative 5. So therefore 7.00 times 10 raised to negative. So the answer is, which the final result of pH is 4.15. So as you can see here in table, we have here the 4.15. So bali, the changes in pH during the titrant of a weak acid with a strong base. So nandito na yung final result na ating nakuha sa ating problem. In example chapter 13 with complex acid and base system. So calculate the hydronium ion concentration of buffer that is 0.0500 mole in potassium hydrogen phthalate KHP and 0.150 m in potassium phthalate. So we have here the HP, as you can see in the value of K is 3.91 times 10 raised to negative 6. So the solution is the assumption that the concentration of H2P is negligible in the solution. So therefore, the solution natin yung sa buffer, we have here the 0.0500 m or mole. So in the second one naman, sa P, with the exponent of 2 negative, so we get the 0.150 m. So therefore, multiply natin and divide by 0.150. So the result is 1.30 times 10 raised to negative 6. So to check the first assumption in approximate value for H2P is calculated by substituting numerals values for H3O positive. So therefore, we get the expression here. So the result is 6 times 10 raised to negative 5 mole. So since the H2P is greater than HP and 2P, so the assumption that react of HP negative to form OH negative is negligible is justified.